Yes.
Are we gonna learn the like radiant equivalent in everything?
In some very specific angles, yeah, the main ones you need to know. We'll be talking about that today.
Did you ever find out why they teach radians?
Yeah, radians have a special application just in like proving certain things in math. Radians are very nice for that. They're able to like create some like beautiful results that wouldn't be so pretty in degrees. So that's the main reason. Okay. So yesterday we did not get very far at all. We just got to the important information you have to know in order to do these problems. So our two cases of the special right triangle and their how the sides compare to each other, their ratios. The original three functions, trig functions, and their three reciprocal functions, and lastly the rule for how the signs behave for each function in the four quadrants. We'll put all of that together in each of these problems. So we're going to start off nice and easy here. Our first example given that theta is 30 degrees, we are going to find all of this information. Theta, alpha, sine of theta, and its reciprocal cosecant theta, cosine of theta, and its reciprocal secant theta, tangent of theta, and its reciprocal cotangent of theta. On a test or a quiz, all of these blanks, and you'll see this on the homework too, it'll already be pre-written out for you, so you won't have to remember everything you need to find. You'll just remember how to find it. First off, you should be able to very easily answer one of these blanks, and that is the theta blank, because we literally give you that theta is 30 degrees. As given in the directions. And believe it or not, I have had students miss that on the test before. So don't be that student. All right, let's graph it. So first we'll graph our theta. Starting on the right side of the x-axis, 30 degrees is going to land us in the first quadrant. So we're not going to make it very far. I will exaggerate it a bit because I will need some space to demonstrate this first problem. So this is our theta, which is 30 degrees. Alpha, x-axis to the angle. We're in the first quadrant where alpha and theta are always the same, so alpha is also 30 degrees. And we can go ahead and fill that in over here. Hopefully all of that up to this point was familiar to you. Now for the new stuff. To find our six ratios, our six trig functions, we have to work with their triangles. So, how you draw the triangle, you start at the arrow of your angle and you're going to connect it to the x-axis. In this case, we're going to drop it down to the x-axis and create that perpendicular with the right angle. Once again, to clarify, this angle on the inside here is a 30-degree angle. This means we have a 30, 60, 90 triangle. Without looking at yesterday's notes, does anyone remember how the three sides compare? 30, 60, 90 in order. Want to give it a shot?
Is it one and tangent, or radical 2, 3?
You're close. You got a little switch. 1, radical 3, 2. That was a really good guess, though. 1, radical 3, 2. Those are the side lengths. And remember, the 1 is across from the 30. So across from the 30, that's going to be our vertical here. This has a length of 1. The 60, that's the angle up top. So across from it, that put us on the horizontal. That has a length of the square root of 3. And then our hypotenuse gets the 2. Hypotenuse is always across from the 90. Lastly, we need to label the sides of the triangle as H, O, and A. We need those in order to find all of our trig functions. H, the hypotenuse, always across from the 90. O is opposite the alpha, the given angle. So O in this case is 1. And that means the A is going to be the square root of 3. If you're looking for a pattern to make here, O will always be on the vertical and A will always be on the horizontal, if you want to just remember that. O equals vertical side. A equals horizontal side. Give me just a sec. So your angle is always going to be drawn out from the origin, and when we connect it to the x-axis, it's kind of hard to show without, I could just draw all four real quick just to demonstrate my point. This will only take a moment. Here are your four possible configurations. And on all of them, the angle, the alpha, is always going to be that inner angle connected to the origin. So the opposite from our given angle will always be the vertical. So there won't be a case where this rule is broken. O will always be the vertical side. And the A, the adjacent, will always be connected to the angle itself. That's the x-axis. Does that clear that up? Wonderful. All right. We've done most of the work. Now let's find our 6 trig functions. So sine of theta, sine has a ratio of O over H. So that is 1 over 2. What is it? No. Just like it as a fraction. Cosecant is its reciprocal, so flip it. Cosecant is 2. Cosine is A over H. So that's rad 3 over 2. For secant, we flip it. 2 over rad 3. Now 2 over rad 3, there is something improper about that answer. What is it?
You can have a radical on the bottom.
No radicals on the bottom. Let's fix that. So the trick is to multiply it by the radical, top and bottom. So times square root 3 over square root 3. On the top, 2 times square root 3, just put them together, 2 square root 3. And what's the square root of 3 times itself? Nope. Just 3. When you multiply a square root by itself, the square root just disappears. Another way you can think of it is this will become square root 9, and the square root of 9 is 3. That's why that trick always works. Last one, tangent. Tangent is over A. So 1 over square root 3. Same case here, we can't have that square root 3 on bottom, so we'll multiply top and bottom by square root of 3. And that gives us the square root of 3 over 3. And lastly, cotangent. Again, take the reciprocal of tangent. Now, if you take the reciprocal of the final answer, if you think about it, we're going to have a square root of 3 on the bottom, and then we'll have to get rid of it. If you take the reciprocal of the original fraction, we won't have that problem. So save yourself some work and take the reciprocal of the original. This would just be square root of 3 over 1, or just square root of 3. Questions on this first example? Hopefully you agree with me when I say this isn't necessarily difficult, it's just a lot of work. With enough practice, though, you'll see these problems are actually quite quick. Let's do another. Example 2. Theta is 120 degrees. And I'll write out these same blanks as above. Theta, alpha. I'm going to go down first, do sine, cosine, tangent. Sine of theta, cosine of theta, tangent theta, and the reciprocals, cosecant theta, secant theta, cotangent theta. Start by drawing the plane. Again, we already know theta, it's 120 degrees, it's given. $120, that's going to land us in the second quadrant. This is 180 degrees on the left, and up top here we have 90 degrees. So 120 is in second quadrant. Angle of rotation, starting point up to where the angle ends. Theta is 120 degrees. Next we draw alpha, x-axis up to where the angle ends. Altogether, alpha and the theta make 180 degrees. So if theta is 120, alpha is going to be 60 degrees. I'll write that workout here for anyone who wants to jot that down. 180 minus 120. So alpha is 60 degrees. So this angle right in here, 60 degrees. To figure out everything else, we must work with the triangle. Arrow to x-axis. So once again, we're going to drop the side down to meet the x-axis, creating a right angle. Here we have a 60 degree at the bottom, 30 degree at the top. Once again, this is a 30, 60, 90 like the triangle above, but the adjacent, not the, well, I guess the adjacent, but the alpha is 60 this time instead of 30, so our sides are going to be flipped. So across from the 30 at the bottom, we have the 1. Across from the 60 on the side, we have the rad 3. And then the 2 is still the hypotenuse. Before I move on, there is a sneaky detail here that you're going to have to keep your eye out for. As we move around the plane, obviously we've got negatives. We have to worry about negative numbers. One of these sides, the 1 or the rad 3, should actually be negative. Which side is that? It's the 1. Why is the 1 actually negative 1? Not necessarily. Yeah.
Because it's on the x axis, and it's going away from that origin. So
Yeah.
it's gonna get negative.
It's on the left side of the x-axis where the negatives are, so that's going to give us a negative 1. The rad 3 is parallel to the positive, the top part of the y-axis, or you can think of it as it is above the x-axis. That's where the positive y's are. Yes?
If our theta with something greater than 180
Mhm.
descending,
Mm-hmm.
would that rad 3 and the negative, would the rad 3 and the 1 be negative?
Correct. Yes.
Thank you.
You're welcome. The one side that will never be negative is the hypotenuse. Hypotenuse is always positive, and that's because of Pythagorean theorem. If I take these two sides and say they're both negative, I'm still going to get a positive answer for my hypotenuse. So, this will never be negative, but the sides on the x and the y might be. Got to look out for that. All right, now I will label my sides HOA. H across from the 90 is the 2. O is opposite the alpha. It's also on the vertical side, always. A is the negative 1, the adjacent. Now let's set up our trig functions. Sine O over H. Rad 3 over 2. Cosecant, flip it, 2 over rad 3. And we need to fix that. This is going to be times rad 3 over rad 3. And that will give us 2 rad 3 over just 3. Cosine A over H. That's negative 1 over 2. So just negative a half. Secant, flip it, it's negative 2. Tangent, O over A. Rad 3 over negative 1, so negative rad 3. Cotangent, flip it. So that's negative 1 over rad 3. And again, we're going to have to fix that. Times rad 3 over rad 3. That gives us negative rad 3 over just 3. Before I move on, I haven't shown you yet how to incorporate the plane rules for each quadrant. This is used as a check on your answers. It won't obviously tell you if your whole thing's correct, but it will definitely tip you off if something is wrong. So, in the first problem that we did, this was in the first quadrant. And in the first quadrant, all of these are positive. So this is A for all. So you make sure that all of your functions here, sine, cosine, tangent, and the reciprocals, all have a positive value. In our second problem, we're in the second quadrant. And remember, the acronym was all students take calculus. We're in the second quadrant where S is for sine. In our second quadrant, sine should be positive. So make sure that your sine and cosecant values are positive, and then make sure the other two functions are negative, both for themselves and their reciprocals. This is how you catch your mistake if you forget to label one of these as negative, for instance, or if you mislabel something as negative that's actually positive. 9 times out of 10, this rule is going to catch that mistake. It's just something to be aware of. Any further questions on this problem? We're going to do one more in degrees. And this is something that came up on your homework we haven't talked about yet. So I'm sure it'll be very helpful for you guys to see. The practice packet.
Oh, okay.
A negative angle. We haven't done one as a group. Theta is negative 225 degrees. Let's fill in our blanks. We have theta, alpha, sine, cosine, and tangent. And the reciprocals, cosecant, secant, cotangent. When one of these appeared on an assignment last week, I got a lot of questions about it. So I wanted to show you how I like to graph negative angles. First thing I do is I visualize what it would be if it were positive. So first I'm going to graph, and I'm going to do like a miniature graph here just to get my point across. So if we did positive 225 degrees, we have 180 here, and then the bottom is 270, so that would put us in the third quadrant. So if we go the correct direction, 225 puts us in quadrant 3. So if we go backwards, we're going to go that same number of quadrants in the opposite direction. If we have negative 225, we start at the same place, but instead of going counterclockwise to the left, we're going to go clockwise to the right. And I'm going to go through 3 quadrants. 1, 2, 3. I'll stop in quadrant 2. So my advice for this specific problem, move through three quadrants. If you don't like that, there is another way to see this, and it works for any angle, regardless of which quadrant you're in. You can graph the positive direction and then just flip that over the x-axis, and you'll end up in the correct quadrant. So that's another option. So I'll add that as well. Or flip the positive angle over the x-axis. So whichever way makes more sense to you is fine with me. So now that we know what the graph is supposed to look like, that's going to make graphing it a bit easier. Theta we can already fill in, we know is negative 225 degrees. And let's graph. So we know this is going to land in quadrant 2. Reminder, when you graph a negative angle, make sure you're drawing in the opposite direction. Alpha goes from the x-axis up to where your angle ends. So we have 180 degrees here. And again, our theta is negative 225. This came up last week, but now you're seeing the reason why. Alpha has to be a positive number. So clearly theta is negative, that's all right, that's allowed. Alpha's inside of a triangle. We'll draw the triangle in a couple minutes. Angles inside of triangles are always positive. There's never a case where we can have negative angles inside of a triangle. So when we do this math here, we're going to remove the negative from the 225 when calculating the alpha so that we're not trying to force the sign to work for us. So thinking back in terms of positive numbers, this curve here is 225 degrees, and then up to the x-axis, this part's 180. So 225 minus 180 will give us the portion that is alpha. Alpha equals 225 minus 180. And 45, thank you, that's correct. 45 degrees. So alpha is 45 degrees. And down here, because I don't really have space above, I'm going to add the note. Always positive. All right, we found alpha and theta. I'm going to write that into the triangle itself. This is 45 degrees. Now let's make the triangle. We go from arrow to x-axis. So the side comes down and makes a right angle. This time, we have the 45, 45, 90 scenario. What are the side lengths for that triangle? One, what?
So it's always inside the 3 above.
What's the length of the side that across from the 90? The hypotenuse?
No, like the 3 above. And one's for the 60, 90.
Yeah, so then what would it be for 45, 45, 90? Oh, you can say square root.
Yeah, I was trying to think of it.
Yeah, radical, square root, those are both correct. So, both of these angles are 45 degrees. So their sides across from them both get a length of 1. And then the side across from the 90 is the rad 2, the hypotenuse. Just like the previous problem, the horizontal side is a negative 1 because we're on the left side of the x-axis where the negative numbers are. Lastly, we label HOA. H hypotenuse, rad 2. O is on the vertical, and A is on the horizontal. And now we fill in our ratios. Sine is O over H. So we have 1 over rad 2. can't have that as an actual answer, so we multiply by rad 2 over rad 2. And we get rad 2 over just 2. Cosecant we flip, and we're going to flip the original number, so we don't have to do that work again. That will just give us rad 2, square root of 2. Cosine a over h. So that's negative 1 over rad 2. And if you don't mind, I'm going to skip showing that step because it's going to be just like the sine number, except it's going to have a negative on it. Negative rad 2 over 2. Secant, flip the original. That's negative rad 2. Tangent, O over A. We have 1 over negative 1, so it's negative 1. And if I were to flip that, that would still be negative 1. Lastly, again, it does not hurt to check the signs of your answers. So we're in the second quadrant. Once again, sine should be positive. The others should be negative. So make sure sine and its reciprocal function are positive answers. And then the other 4 all have negatives on them. And I think we're going to stop there today because radians takes a little bit longer to explain, so we'll pick that up tomorrow.